In match problem 2, we have a company who's manufacturing headphones for MP3 players. We're given a price-demand equation and a cost function. And what we want to do is start off by finding our marginal cost at a production level of 3,000 units, and our marginal revenue at a production level of 3,000 units, and our marginal revenue at a production level of 6,000 units. So the first trick here is that we are not given a revenue function. If we're not given a revenue function, then the very first thing we need to do is establish that revenue function. So we'll start by solving that price-demand equation. For P, so that we get something of the form P equals some expression in terms of X. So we can start by subtracting 10,000 from both sides, and then dividing both sides by negative 1,000 will give us P equals 10 minus 0.001 X. So now what we have is that exact same price-demand equation, but now written in terms of X, which means we can find our revenue function. So keeping in mind that our revenue function, R of X, is always the number of units sold times price per unit. So here we'll just take X times our price function, 10 minus 0.001X, to get 10X minus 0.001 X squared. So we have our revenue function. Now we need to find our marginal revenue function so that we can evaluate it at our two values. So in this case, our marginal revenue function is just the derivative of that revenue function. So that's going to give us 10 minus 0.002 times X. So now we're ready to find what the question's actually asking us. Find our marginal revenue at a production level of 3,000 and at a production level of 6,000. So R prime of 3,000, or our marginal revenue function evaluated at 3,000, is going to give us 4. And our marginal revenue function evaluated at 6,000 is going to give us negative 2. So now what we want to do is interpret those results. So explain what that means, that we know our marginal revenue is 4, we know our marginal revenue is negative 2. So if we get a marginal revenue of positive 4, since that marginal revenue value is positive, that tells us that if we increase production, we will increase our revenue. Because the revenue that we'll earn from producing one more unit would be $4 additional. So increasing production is going to increase our revenue at this point. If we look at that production level of 6,000, our marginal revenue is negative 2. So increasing production by one more unit would decrease our revenue by $2. So in this case, we would say that increasing production will decrease our revenue. Or alternatively, we could say that if we decreased production, that would increase revenue. So this always tells us our relationship, what's going to happen if we increase our production. So if increasing production is causing us to lose money, our better option would be to decrease production, and that would help us bring in more revenue. In part B, we want to basically complete the same problem, except now we're looking at the profit function, so the marginal profit function at a production level of 2,000 units, and marginal profit at a production level of 7,000 units. So the first thing we need to do, since we're not explicitly given a profit function, is establish that profit function. So our profit function is always our revenue function minus our cost, so how much money we brought in minus how much we had to spend, which is going to be 10x minus 0.001x squared minus our whole cost function, so 7,000 plus 2x. So we can go ahead and distribute that negative through the parentheses. So this will become minus 7,000 minus 2x, which is going to give us a profit function of negative 0.001 x squared plus 8x minus 7,000. Once we have our profit function, then we can find our marginal profit function, which again will just be the derivative of that profit function. So our marginal profit function will be negative 0.002x plus 8, and then minus 7,000 as a constant, so that just becomes 0. So then we want to find and interpret our marginal profit at a production level of 2,000 and our marginal profit at a production level of 7,000. So we would plug 2,000 into our marginal profit function, and we get a value of 4. We would also plug in 7,000 into our marginal profit function, and we get a value of negative 6. So the interpretation here is exactly the same as for the marginal revenue function. If we're at a production level of 2,000 units, increasing production by one more unit should increase our profit by about $4. So increasing production will increase profit. But if we were already at a production level of 7,000 units per week, then increasing our production by one more unit would actually negatively affect our profit. It would decrease our profit by about $6. So increasing production is going to cause us to lose profits. So increasing production will decrease profit. Or, again, the other way we could say that is that if we decrease production, then we'll increase profit.